No.
Which exam? I don't have exam.
No, eso le dice para esta clase.
Alright, it's running, it's recording. No. What were the questions? Fall
8.
what?
8.
Which one is this?
On fall 2010.
No, this
Oh, we did that
was
one already.
We did with a 50%.
That's a stop losing. No, that was what?
okay, so this is
Number
spring 2009 problem 7.
Ask him this one.
I'll
We clarification was just last year.
Okay, so the Evergreen Salad Company asserts that on average its packaged salad greens remain fresh for 4 days after the use by date on the package. Standard deviation is 0.45 days. Assume the length of time a package stays fresh after the use by date is normally distributed. So we know we're using a normal distribution. Okay. What's the probability that a randomly selected packet of greens will be fresh for more than 5 days after the use by date? In part B. Okay, well let's deal with that. So first, what is the probability that a randomly selected package will remain fresh for more than 5 days after the use by date? So you know something is normal or binomial. What you want to do is you define that random variable, the thing you want to track, right? So here I'd say let x be the number of days fresh after the use by date. Okay. So now it says, what is the probability that a randomly selected package will be fresh for more than 5 days after the use by date? So in part A, we want the probability that x is greater than or equal to 5. Well, it says more than 5 days, so greater than 5. And I know x is a normal distribution. I know mu is,
It's 4.
right, so we're given that mu is 4
70.
and sigma is 0.45. So what do we do here?
Assume nothing length of package.
Plug in the equation.
What equation?
The z is equal to x.
The z-score. So you know this would be equal to
X
z
minus
is greater than 5 minus mu over sigma.
yeah.
Okay. So what is that?
Isn't that like 1 something?
Wait, how did you get 5?
That's what they asked in part A. They asked, what is the probability that a randomly selected package will remain fresh for more than 5 days
Okay.
after, right? X is the number of days it's fresh, so I want x to be more than 5.
So I got 2.22.
So this would be 2.22, and so what you do is you look that up in the table. So this is going to be 1 minus the
What?
table value for 2.
Is that because it's greater than? So we
Yes.
have to do, okay.
Wait,
Because remember the value in the table tells you what's less than z,
Sorry.
right? So if you look up a given z value, the table will tell you what's less than that value. So if that's 2.2, it'll tell me that, but I want this, so I'm going to take 1 minus that.
so wait, does it matter what if it's greater than we subtract, or it doesn't matter? What am I saying? So like if it was less than, would we still have to subtract?
No.
No.
Oh,
If
okay.
it's greater than.
The table
That's what
tells
it
you the
tells
less
you.
than value.
Yeah.
Oh, it tells you the less than. Okay.
It always helps to draw this table.
Okay.
Yeah, so I know that here I'm at 2.2. The table is going to give me everything over here. That's when you're less than 2.2. You want to be bigger than 2.2.
In the middle will be 4, so that you know on what side you're on.
Okay.
So you look that value up in the table, and what do we get?
Oh, I don't.
It's 1.00 something. Check it out.
Wait.
I got 0.9864.
2.2
What?
here.
0.9864.
Oh, my fault.
0.9864.
Oh, this is subtraction.
Yeah.
And then you subtract that from 1. So
9868.
Yeah, we got 968.
968.
Yeah.
0.22.
0.22, yeah.
So it's 0.0132.
0.0132. So that is the answer to part A.
So that's 1%. So this is saying that
Yeah.
after 5 days.
About 1% of these products will last for more than 5 days.
Only 1%.
Yeah. after the use by date.
I got a question about this. Is a funny question. I've been meaning to ask you. What is that 0 with the slash?
Like,
Oh,
that's the
this,
area.
this just means the table value.
No. That
The
symbol.
fee, he means fee.
Oh, it's called fee. It's just a letter.
Oh, that's it.
It's, yeah.
It's green.
What does it mean?
It's
In this context,
like-
that's what it means.
it's like delta lambda.
Like
It's
means
just-
what? You saying that's what it means? Means
And the
what?
table
Oh, the
value.
table
Oh.
value, the area that's covered.
That's just
Oh,
the area. This
okay,
means
okay.
the area
Got
to the
it.
left.
Yeah.
Okay.
It's okay, I just
Z.
do it as fee.
And Z.
Basically, this is the same as saying the table value, right? The value that you look up in the table when you look up 2.2,
So it's
the
all-
value that you get. You know?
Yeah.
Think of it as a function, like f of x. F
Oh.
of x is the value in the table.
Thank you. Now I get it.
Yeah, but it's a Greek letter. It's called phi.
Got it.
So it's the table value for z.
What you call it?
May.
You know this one.
Now part B is it's a little sketchy to set up, but once you get it set up, you can. It's not so bad. Right, so it's decided to offer a refund for packages that are not fresh X days after the use by date. Find the largest value of X so that the company can expect to issue refunds for at most 1 out of 250 containers.
Wait, what?
One more question.
Yeah.
Companies
That's what I was like,
to offer a refund for packages.
So back to the original question. They said what percentage, right?
This is 1%.
So, so you want us to like move the decimal form, or we could leave it like this?
They never ask for a percent, they ask for probability.
Oh, probability?
So that would be.
Oh, okay. Never mind.
So the use by date is 4.
Yeah, so the company is like, okay, we're gonna give you a refund if our product spoils this long after the use by date, right?
So are we looking
You
for
wanna
the
figure out
X?
what is the number that they should say, so that they don't have to refund a lot of money. They only have to refund 1 out of every 250 packages, right? So that's the idea.
So we're trying to find the X?
You're trying to find the X, right?
You going backwards?
Yeah.
Kind of, yeah.
So are
So-
we doing 1 out of 250? That's,
Well, what is the 1 out of 250?
that's how much they want to issue, so is that our X? No, that's not our X, that's,
How much they want to?
is that N?
No, we want the probability that X is less than X is 1 out of 250.
Okay.
Do you see why?
Yeah, because we're trying to find
Nope.
that X. I don't know how to explain.
Nope, I don't see it.
Yeah, I don't know.
You want the maximum amount of time that they can say that the chances of it spoiling before that is only 1 out of 250.
Okay.
Because
so
if it
the-
spoils before that, they have to refund your money. They don't want to refund your money, right? So they're like, the most we want to refund is 1 out of every 250 packages. When would we refund it? Is if our thing spoils before we say it will, right? So they're saying, what is the date that they should say,
Oh.
so that if it spoils before that, they'd have to refund your money, right?
Got it.
So the thing is, I want the number of days it stays fresh. If it's less than that date, I want that to happen at most 1 out of 250 times,
Oh.
right?
And-
So that's a probability. 1 out of 250 is actually what? Put in that calculator.
0.004.
0.004.
4.
Okay.
Uh-huh.
Okay. So now, in the table,
We find that number?
So now we have to go back.
find the area 0.004. What's that going to give you? So you're going to backtrack and find the Z
Yeah.
after finding that value.
Oh, there's so many.
That's not it.
So there's a range.
Find the closest one.
It's 0.004,
Oh,
not
2,
0.000. Right here. Bam.
Bing. Negative 2.65.
Minus 2.65?
How did you know to look on that? Oh, because it's less than?
No, because it's a probability.
Oh.
The numbers on the table go from 000 all the way to 01, 02,
Oh, okay,
03 to
because-
the right.
Got it.
Okay, so I know Z is equal to this, but we also know that Z is equal to X minus mu over sigma.
And we use the same mu and sigma as before.
Yeah, it's the same question. So minus 2.65 equals X minus 4 over 0.45.
Oh.
So this would mean the X value that we're looking for is going to be 0.45 times minus 2.65 plus 4.
I got two, okay.
2 point,
2.8075.
2.8?
Yeah, let me try again. You said negative 2.65 times 4, right? 45?
Yeah, point times 0.45 and add 4.
This is, oh. Yeah. That's what I got.
So you should choose x equals 2.
You got 2?
They should say 2.
Because you want it to be less, right?
Yeah.
Then, because if it's closer to 3, then it'll definitely spoil.
Yeah, because it'll only make it to like 2.8 on average. So if you tell them, oh, it'll spoil after 3 days, no, that's too long. I'm going to have to refund more than that.
Okay.
Right, so 2 days is the optimum they should say, the maximum. Right, so if they say, you know, our crops will stay fresh up to 2 days after the use by date, the probability that something will spoil before that is actually this often, and then they issue a refund.
Oh, they give me something.
The reason you don't choose 3,
Because you want it least, right? It's because it'll definitely spoil at 3 days.
No, I think it's a higher probability
Yeah.
of 3 days, so they will spoil.
Yeah, it'll spoil after 2.8 days, which means after 3 days, there's more time to get spoiled.
so you want it to be less.
You want it to be less so that it guarantees that you don't have to pay, you don't have to refund.
And they're telling you how less they want, and just 1 out of 250.
Yeah,
The language is being used in this question.
yeah, that one's weird.
So this is not into
So what are you gonna give us on Wednesday's exam?
I mean, we're the only ones here, and we can shut the camera
Yeah.
off.
It's funny how we just recorded that part. Imagine, what a brief
Or it
pause.
just mutes and like nobody knows
Well,
what's
you can
happening.
edit.
Imagine how you
Like
get here
cover
so
one
fast.
thing to the other, and like, so anyway.
Pause it.
I just jump over there.
Yeah.
What happened?
Pause it. Pause it.
Wait,
The language.
things are different.
You know, since we
It's dark.
stayed behind, you can just,
Yeah.
you know, just.
Suddenly it got darker outside,
Suddenly it got
like
darker
from one
outside.
frame to the other, suddenly it's like super dark. What did he tell them?
This one is so mean.
Are you ready for
Yeah, what's it?
You
Another
bet
question?
you, bro.
2008,
Another question.
I think, number 10.
Listen, you're gonna wait till today to ask us this
Well,
question.
fall
Where were you?
For the
Oh,
back.
I'm sorry.
Here now?
Fall 2010, number 2.
I thought we did that one.
Tu marica se sabe todo. Ya no le pedí attention to me.
Is that the one?
I think that's what we did.
The 50% one?
Oh no, we
That's
didn't.
9.
This is the one we did 9. Sorry.
Okay, so fall 2010, number 8, the polling organization one?
Yeah.
Okay, so it says a polling organization claims that 15% of New Yorkers favor returning to a free tuition policy at CUNY. Assuming that were the case and a random sample of 2,500 New Yorkers are surveyed, what would be the expected number who would support the proposal?
It'd be a probably.
Okay, so A. 15% support the policy. So what is the expected support out of 2,500 people?
7.
That's basically the question. So what do you think?
17.8. So you have to find NMP, which gives you mu, which is equivalent to expected number of support,
Okay, so why would you find NNP?
because it's
That means you're thinking of it as a binomial.
yes.
Why is it a binomial?
Because there's a pass and fail. The pass is a 50%, and the fail, the support is 85%.
Right, so you're repeating an experiment 2,500 times. Basically, you're giving someone a poll. They can either support the thing or oppose it. Right, so there are only two possible outcomes. They're all independent, so it's actually binomial. So now I can think of things in terms of N, P, Q, and all that stuff. So N is 2,500. P would be 15% or 0.15. Therefore, my Q would be 0.85. Right? And so now expected value. Remember, the expected value is the same thing as the mean, And then the mean we know is n times p when we are a binomial. So that's 2,500. We expect 15% of those people to support it. So you just multiply that by 0.15.
17.8.
17?
Yeah. Oh wait,
No,
sorry.
it has to be
375, that's the sigma.
That's the number of people you expect to support this
Yeah.
legislation.
375.
Okay, so now in part B, assuming the claim stated in A, what is the probability that fewer than 13% would favor the tuition policy? Okay, so first of all, I figure out how many is 13%.
375.
So that X equals the number who support the policy. 13% of 2,500 is
325.
325.
Mm-hmm.
Okay, so we want basically here, it says, what would the probability that fewer than 30% would favor the probability, right? So this is the probability that X would be less than this, right?
Okay. So that's
What's the probability that the number of people who support this will be less than 325 people? But I know this is a binomial, so what would that mean?
You could zig the C score, Z score.
I obviously want to estimate it, right? Because if I'm doing this by the binomial, I have to find probability of 0, 1, 2, 3, all the way up to 325. Ain't nobody got time for that. So we're going to switch to the z-score, right? So this is z is less than. Now I'm going to do the z-score.
Is it 325 minus 375?
Sure.
No?
Yeah, and then 325 minus 375 over.
17.8.
We have to find out what the theta is.
Right, so I know that this is mu, right?
Yeah.
So
What is my sigma?
375
17.8. Oh, NPQ, square root of NPQ.
Yeah.
It's 17.85. Yeah.
So, right, note, the sigma is going to be the radical of NPQ, which is going to be, it's 17.8.
85.
That's
Okay, so now I'm going to do x minus the mu over the sigma. But
Is it estimated?
we have to do a continuity correction, right? Because remember, this is binomial, and now I'm using a normal. So once you use a normal to approximate a binomial, you have to do continuity correction. So do I add a half or subtract a half?
You add?
It's less than, so that means that you have to subtract. Z is. But then you
Is
have
this
to
an
add-
upper bound or a lower bound?
Upper bound.
Right, you add a half to the upper bound, you subtract a half from the lower bound. So here we're going to add a half.
Can you show that again, how you would determine?
It's less than 375. 375 on the right side.
All right, down after. But for now, just remember that we add a half here.
Number 375.
And so I take 325.5 minus this over that. What would I get?
X is greater than 275. Then it's zero.
325.5 minus 375.
Negative 2.83.
Negative 2.83. So now we're going to look that up in the table. And what do we get?
Negative 2.8.
0.0023.
And that's your answer, because we're looking for less than, which the table already gives us less than.
This
Can
question's
you
wrong.
please explain why you added 0.5?
Right, what gave you, what in the problem gives you that idea?
The problem didn't, the inequality did.
What does
This
the
sign
inequality show?
tells me if I should add or subtract.
So if it.
No, I think what they're asking is like, how did you go from estimating, no, from actual to estimating?
How?
Yeah.
What do you mean? I just decided to do it.
What do you mean?
Wow.
So how do we know what to
In the
decide?
exam.
Well, I just told you, if we know this is a binomial, right?
Yeah.
We had that before. So if you're computing a binomial for less than 325, what does that mean you have to do? You have to do that formula, right? N choose k, p to the k, q to the n minus k. You have to do it for every single value less than 325.
You don't wanna.
You have to do it for 0, 1, 2, 3,
Up to
4,
25.
324 times. You're not going to want to do that. That doesn't make any sense. And they're like, oh, we can do the complement. There are 2,500 people.
Yeah.
The complement is even worse,
Yeah.
right? You're going to have to do it more than 1,000 times if you do the reverse, right? So you can't do hundreds of calculations, so you decide to estimate it. Now once you decide to estimate it, you can use a normal to approximate or estimate the binomial. Now once you do that, you have to do a continuity correction. So you're going to have to either add a half or subtract a half. And the rule for adding a half or subtracting a half comes from that formula I gave you before, where it says that if I have a probability of x is between a and b, where x I know is binomial, then this is the same as the probability for z is between these two numbers. It's a minus 0.5 minus mu over sigma up to b plus 0.5 minus mu over sigma. In other words, you add a half to the upper bound, you subtract a half from the lower bound.
Okay.
Right? So basically the way the inequality is turned is going to tell you whether you want to add or subtract a half. Now notice over here, this part wasn't there. My inequality was pointing that way, right?
Okay.
So it means this number is an upper bound. It's bigger than the z. If you're bigger than the z, you add a half. If you're smaller than the z, you subtract a half, right? So here, this is like my z would be on this side, that's the upper bound.
It's on the other side, so those it's greater than 225?
What happens?
Funny one.
It'll be you, yeah.
Okay.
Now when you say subtract
Right,
a half,
so-
I guess that's.
You literally subtract a half from that number.
oh, the 0.5, okay.
Yeah, so this number here, that x
Oh,
value 325,
yeah.
I'm going to add 0.5 to that.
Got it.
And then do the z-score with that new number.
Okay.
Right? The only time you do this is when you're estimating, is if you had a binomial before and you're using a normal.
But it's less than, so aren't we subtracting?
What's less?
X.
The 325 is greater than.
Oh, if that number is greater than, that's what we're looking at. Oh,
The inequality sign is pointing towards that guy.
okay. Got it, got it.
The
Okay.
inequality sign is pointing towards that guy. It points towards the guy.
So if it was the other way around, then we would have to minus. So those x
Yeah,
is
so
greater
if
than
it was something like x is greater than 325,
Okay.
then this is pretty much the same as saying the number is on this
It's
side.
on this side, yes, that's good.
Right? Because it's pointing away from the 325. It points away from the lower guy. So you subtract a half here.
Got it.
So basically you add 0.5 to the upper bound. Right? That's to the bigger guy. You subtract 0.5 from the lower bound. Now, sometimes you don't have like an inequality on both sides. Sometimes you might just have half of these and you have to know which one to pick. Right? You're basically looking where the inequality is pointing. Right? Is your variable bigger than the number or smaller than the number? If your variable is bigger than the number, you subtract a half. If your variable is smaller than the number, you add a half.
Okay.
So this is called continuity correction. Use if you have a binomial but want to approximate or estimate it with a normal distribution. And usually the word approximate or estimate would be a part of the question. They'll say approximate this probability, and so you know you have to do like a continuity correction. But it might not say that. Basically, you have to know that you had a binomial in the beginning, you want to use a normal to find the answer because the binomial has too many calculations, right? Whether you do the complement or not, it's just too many calculations. And I can't sit here to do hundreds of calculations,
That's right.
right? So you just, this allows us to only do 2 of them, right? Just look up something in a table.
Alright.
Any other questions or?
Bassett waited like 3
Yeah, so
semesters
the-
to ask questions.
Yeah, the test on Wednesday is going to be short. It's pretty much on binomial and
Is it ever going to have questions?
Is it gonna be in chapter 13?
Yeah.
And
13 and 14.
I know, but are you gonna focus a lot on 13?
Half and half.
It's a binomial and distribution. What is that?
Binomial and trinomial.
Everything with binomial and normal.
So next
Bassett waited all semester
To ask questions.
to ask questions.
At least he did. We didn't even do that. I'm gonna ask him
But
on
I
Wednesday.
learned myself, so.
I'm gonna ask him on Wednesday.
But you know, I just wanna
Alright, get
like,
away from the camera.
I just really wanna say thank you for like, you know, taking your time to